Hello, my name's Richard and I'm a tech lead at Prem, and in this video I'm going to talk about Ayup, or Ayup as it's presently called, which is a deploy from source solution. Um, so the idea behind Ayup is to push the envelope in how easy it is to deploy, well, build and deploy software on your own infra or in the cloud, wherever. And it's initially targeted at AI/ML applications. Prem is an AI company, and so let's imagine that you're like a junior AI/ML engineer, and you've created a project that does some inference. So you've either used a pre-trained model or you've done the training already, but then you need to deploy it to a server somewhere, um, maybe like AWS, or perhaps it's like a machine in your company's basement that you need to use. And you don't know too much about Docker, you don't know anything about Kubernetes, and you don't want to know. This is where AUP comes in because you just point it at your code and it'll deploy it. Uh, and if your target machine doesn't have AUP on it already, the plan is that the AUP server components will be really easy to install as well. So you just do a one-line install to put AUP on the server, then you just download the CLI application for your machine or machines, um, do a login to the server just to connect the two, and then you can push your application, and AUP will do some port forwarding so you can access your application when it's running, and it'll also serve the application from the server as well. And we'll have like a bunch of services around that to make that application publicly available or not. So yeah, so AUP, both the client and the server are open source. You might have some other bits and pieces that are closed, but or you'll basically be able to run everything yourself for small deployments. Then we'll have convenient stuff that's closed, perhaps. Okay, so I'll get on to a demo. Um, okay, so first of all, what we need to do is we need to log into my remote machine where I want to deploy my application, uh, which is a Dell, as you may be able to tell from the name, Richard Dell. And today, IUP being in the early stages of development, running the server is a bit more complicated than I want it to be. So today, I'm going to start the server by using Nix, the Nix package manager. Um, so first of all, I need to start build kit, which is what we use to build containers behind the scenes. So I need to do, okay. So this will start the dev portion. Okay, so that's got build kit running. We'll bundle that eventually with the IOPS server, but for now we have to run it separately. And then we're going to run the IOPS server, which again, uh, unfortunately, it requires running Nix. So don't get any output from the server log output. But yeah, you can see that I'm specifying the container D socket, and then we use a Nix command to set up the environment that the server needs and runs it, which is actually it's quite easy to install Nix. The instructions are on the README, but it's not exactly what we want. So eventually you'll just be able to run the server without root. We'll do a rootless install, but for now it needs to be ran as root, and you need to do things like specify the container D sockets, which, by the way, it integrates with container D. So ultimately, like the containers it produces will be available to Kubernetes if you're using the Kubernetes container D, and you'd have some integration there. But again, this is just like a compatibility thing. Like the idea is you'll just run the Ayup server as the default, and it'll be easy to do. Okay, so now we have the server running. We have to go into our example folder, and we'll start off by running a really simple application. We just do AY push. We've had to specify the host that we're using. Yeah, again in the future you'll have like you'll do like AY login, and that'll like set up the connection to a particular host and stuff, and we'll have like a nice way to do that that doesn't involve encryption keys or anything. But for now, we just specify the host here on the command line. So let's do the push. Okay, so again, like within the vision of Ayup, it's like when you just try and do AY push on a project, and it's not completely clear how we should run that project, then Ayup will ask you questions. So you'll get an interactive like dialogue between you and Ayup saying like, "Oh, do you want to do this? Do you want to do that?" And trying to guide you through doing it. So even if Ayup can't do it all automatically, which in the on the happy path, it'll just figure it out and do it. But let's say there's some ambiguity in the project we haven't got a playbook for dealing with, we'll ask you a question and see how it goes. Or in this case, we're asking, do you want to create the requirements text? Which, if you have a Python project and you don't specify your requirements, then we need to somehow find out what dependencies it has. And if we click yes to this, it's going to use piprex to try and guess those dependencies, which is just a script which just looks at the imports and whatnot. Okay, so now that's running. The container image was cached, so it all happened very quickly. You can see that buildctl ran, which we use with buildkit, and did everything. So now that container's running, and I believe we can do curl and then go back to the previous one, localhost 5000, just hello world. So we're doing a curl to our local host because Ayup is forwarding the ports. It's forwarding port 5000 from the server to our local machine, so we can do that. Okay, let's move on to a more interesting example. Okay, so if I just show you, so that was all we were running there. Going back, let's do YOLOV. Okay, so this is a slightly more interesting example. So again, look here. So for this one, we have requirements. We also have a dot. We have a virtual env there, which is what the .venv is, but we're going to ignore that. When we upload it, we ignore dot files for now. So if we look at main, a little bit more complicated, but it just starts up a Gradio interface and uses some image recognition library. Okay, so let's push this now, see whether we have this container image cached. Okay, again, it's all cached. It does take a while to build the container the first time you do it, but once you have most things cached, then it does it very quickly. Even if you change the requirements file or something like that, it still has most of the Python dependencies cached. So you actually spend the most time just waiting for it to export the final image. And if you do something like just change the application code, then it doesn't take long at all. Okay, so it says it's running now. So if we go to our browser, there we go. So we can select an image, which is an image I took. There we go. Got some sheep in there and got 2 cows, which you can see. And again, this is we're connecting to localhost, but this is actually running on the Dell machine. There we go. So if I change something about this, let's say I go to py. Okay, it's saying we don't have those things because the virtual env is not active. But let's say we just change something here. Just yeah. So we've just changed one line of that file. Then we do Ayup push again. It's built the image quickly because it's just it's one line we've changed. Yeah, now you can see that that's changed there as well. So, I mean, currently we don't have like a watch mode, but you could see that it'd be quite easy to implement that, and then you could just like once you update the code, it's automatically redeploy the application. I mean, we can do that. So yeah. And now what we could do is we could try changing the requirements file, which, okay, so we have all of these requirements here. We have quite a large set of requirements, including NVIDIA's CUDA stuff, which is quite hefty. We don't actually need it, which is kind of irritating, but this project doesn't try to exclude that stuff. So if we just add like some random line to this, this is going to invalidate the build kit cache. Exit, and then if we do AY push again, see, now it's having to go through and redo the requirements file in its entirety. But you can see that it's using items from our pip cache. So we don't have to re-download all of that. We just have to go through the process of doing the install again, and there's also like a delay when we publish the image, which to the internal containerd image store, which is kind of annoying. We'll eventually fix that, I hope, but for now that takes a little while. But yeah, as you can see, it's still using some kind of caching, and that'll take a while to install, unfortunately. Yeah, so now we're on the exporting layers point. Okay, so while we're waiting for that, get into where we are at the moment. So yeah, I mean, I should mention as well that another use case for this is if you are like an operations person who does know about Kubernetes and does know, about how to deploy software and whatever, but maybe doesn't know too much about AI ML. The idea is that this will also like provide some help for you there as well by figuring out how to run something interactively without you having to go and read a bunch of documentation and figure out exactly how these Python projects are constructed, because it does tend to be the case with Python that you have like lots of different options for project structures, and you know you can have a lot of like perceived ambiguity, even though actually there's like a clear way to run something. And we'll just like do an auto detection, which is kind of similar to past things such as build packs, and like there's a whole host of software there. But the difference between those and Ayup is just the level of usability we're aiming for. We're just aiming for like a very high level of usability. So we don't want people messing around trying to install Kubernetes clusters if they don't want to get into that. And we also don't want to have like a completely closed source solution where you have no control over the server or where you run your software. We want you to be able to run it. We want you to be able to at least be able to run the application on your own infrastructure. Um, and it's only when you want to do stuff like, say, circumvent NAT, then we'll have a service to help you do that and that sort of thing. Okay, so yeah, the eventual idea is you just be able to have like these simple commands, and then it'll ask you like how to hook these together, how to connect the client and the server and whatnot. As it presently is, if you want to start trying out or hacking on Ayup, you just need to install Nix, which like using this, it's just a one-line install. Like really simple to install Nix with the determinant systems Nix installer, and we use Nix flakes, so it comes with that enabled by default. And yeah, and then you can, once you have Nix installed, you can actually just run Ayup directly from the GitHub repository, which is what I was doing here. Okay, so you can see now this is finished exporting all the layers, and it's running the example again. Right, so okay, just going to quit that. And now we're going to look at the code, and I'm going to ramble on a bit for a bit more about how Ayup is made and stuff like that. So let's have a look at this project layout. So, I mean, we have a slightly odd project layout. I mean, the project is written in Go entirely. We used to have a different language in here as well. I mean, we might still include, it might end up being a multi-language repository because, there's a lot of stuff written in Python to help with Python. So you can't like reinvent the entire ecosystem in Go. But on the other hand, we might just put the Python code in containers or whatever. But at the moment, it's all written in Go. The Go is all in the folder called Go, which is slightly weird. I apologize. The client and server communicate with gRPC. So this is important because I mean, at present, this protocol is unstable and I'm probably going to change it all. But eventually, we'll have a stable protocol between client and server, and you'll be able to in theory, you'll be able to write like a client for the server or rewrite the server. So eventually, we will hope to have a stable protocol, but that's like way off in the future. At the moment, this is just like we're going to change this with every single version unrelentingly, and there's no versioning of the protocol at the moment, but that should change in the future. So, I mean, as it stands today, we break the process down into a sync stage where we copy the files. Then we have an analysis stage where we look at the code and decide what to do, ask you some questions. The analysis stage was actually where we ran piprex and created a requirements file. And then we have build and run. And yeah, my current feeling at the moment is that it was a mistake to to separate the analysis, build, and run stages. Um, I mean, this is sort of like a premature abstraction, I think. So probably what I'll do is I'll combine these three stages and then we'll actually mix them together, especially as there's certain things where you're not going to be able to figure out what you need to do until you actually try to run it. To give an example, you may not be able, statically, you may not be able to figure out what ports an application listens on. You know, that information could be hidden away in some obscure library which, you know, has decided to listen on some port or other by default. I mean, you could get an LLM to read the documentation, but it might just be easier to run the application and look at what ports are being listened on. You know, we can do that, and then you can feed that information back to the build step, or, you know, feed that information back to where you set up what ports. I guess technically it would be OCI or whatever sets up to forward from the container. Currently we use nerd CTL to run the containers, so we'd tell nerd CTL what ports we need to open at that point. But it'd be nice to actually like get rid of this separation of building and running to some extent. You know, this is quite a specific requirement to Ayup's use case, so it's not something that I've seen anyone else want to do. But okay. And we'd also like the analysis and build stage to be joined, especially because, you know, when it comes to doing things like running piprecs, don't really want to run piprecs just on the system, the host system as we currently do. We'd probably quite like to run that in a container, or whatever we replace it with in a container. So there you have it. I'd like to join those together. And then we've got some other, we've got like a login call, which is just a placeholder at the moment. We don't do anything with that. And we have a forward call, which sets up a stream to forward a port. Okay, so we can go and look now at the implementations for these. If we go in here, so I mean, we've separated it out into the client and the server. We have some internal libraries. We go. Our main entry point is here in main, as you may expect. So we use Kong to pass the command line. As you know, if you're familiar, that this doesn't hold any surprises for you. And then, yeah, currently we have both the client and the server in the same executable. We may change that. So we may separate them because we may bundle a whole bunch of software into the server, including containerd and build kit, so that could end up being like a 200 megabyte executable, which is roughly the same size as if you have one of these Kubernetes distributions that bundles everything inside the executable. So we may at that point decide to separate them out and have a separate one for the client, although this code probably won't change. It will just be like a switch you can turn on and off, whether or not to include the client stuff or whether to include the server stuff. But currently that's how we do it, and it's quite nice because you just have the same executable to distribute. The client uses bubble tea to create a nice UI. So go to sync. Still undecided exactly how to go about using bubble tea, but yeah, it's quite nice. So on the client side, we just scan the directory you submit, and then send all the files in chunks to the server. It's quite a simple protocol. At the moment, we only really support running one application at a time at the moment. So we just delete all the previous files that were sent, and the at some point we'll do like a differential thing, so we won't like upload the entire set of files every time. But at the moment, that's what we do, and it's very fast, and it's all sent over gRPC, and gRPC has this nice thing where it has compression built in, so we can potentially compress like larger files as well on the fly to upload them. Yeah, it's called sync, but it's really just uploading them at the moment. Yeah, in the future that'll probably change because, once you get up to like larger projects, you don't really want to be uploading megabytes of files. And also you might have binary files actually in your source code, or you may want to upload a binary from somewhere else. So that could be quite large, especially when you're talking about AI/ML. But for now, that's what we have. And then we go to the analysis. Oh yeah, I should mention like one feature of Ayup that I haven't shown is that it can deploy Docker files, so you can use it as like a way of remotely deploying a Docker file. That I added that because it was easy to add more than anything. Okay, so we have like the analysis stage where we sort of look at what files are present and then send a choice for what we want to do if we can't find something. Actually, we don't give you a choice if there's a Docker file present, but we should do. Okay, so I mean it just sort of at the moment it just sort of records like what we found. There's a bit in here that scans the requirements file and looks for whether we have any Git dependencies. You can actually, in a Python requirements file, you can have a dependency that's straight from Git, in which case you need to have the Git executable installed, because that's what it uses that's what pip uses to download a Git repository. It uses the Git executable. So you then have to look at that and make sure that's installed in the container. And then for OpenCV Python, it needs libgl and libglib to be present, which you have to install through apt with the standard Python image. So we have to scan the requirements and look for these like extra requirements that aren't encoded within the actual that aren't explicitly encoded within pip. And then yeah, and then we're done with that stage and we move on to the build stage, where for now we actually call buildctl to actually do the build. There is a proper client library, but for now I've just used buildctl because it's just more convenient than using the client library and then having to reinvent log output and stuff like that. But we'll probably move to the client library at some point. But what we do is when we're actually constructing our Docker file, well, we don't have a Docker file. We construct sort of the binary representation that BuildKit uses under the hood. So we use LLB, which is like it's like a bytecode which represents the what BuildKit should do, the actions it should take, and we can programmatically create this on the fly, which of course like raises the bar quite a lot for who can therefore write this code, because it's quite difficult to figure out how LLB works in comparison to a Docker file. But it means that we're like programmatically constructing the build instructions on the fly, and we don't have to worry about a lot of stuff that can happen if you're trying to sort of programmatically create the text document. Possibly also opens up some features that would be difficult to use from the Docker file that are in BuildKit. I don't know, but I've gone with that for now, and basically the idea is that we'll come up with sort of ways of supporting like based on our usage, we'll come up with ways of, sort of come up with abstractions that are easier to use than writing LLB directly. But for now, we're just doing that, and we'll come up with something better as we go through the use cases and figure out what's going on. Because we don't want to like prematurely start designing some more abstract way of like creating a playbook or whatever. Which is also one reason why we don't use something like build packs, because they again like have this like separation of detection and build and things, and a whole like a vast array of decisions that were good at the time for build packs, but aren't necessarily what we want with our sort of very specific goals in mind. Having said that, we could support them. I mean, once we realise that an application can be used with a build pack, but it's not, again, it's not really like the thing we're going for there. Okay. And I think that's probably it. So thanks for watching. I suppose there's one last thing I can show. Ayup can in fact build itself. Yeah. Yeah. So I mean, Ayup has a Docker file, which we don't really use, but it's basically the Docker file for Ayup just calls Nix. It just uses the Nix container, as you can see there, and just creates a Docker file from using the Nix expression, and it will be possible. I mean, it is possible now to run Ayup in a container. So you could run Ayup in Kubernetes, whatever. I haven't actually done that, but you just run it in a container with privileges, and it hook back into the Kubernetes containerd instance, which you're actually running Ayup on. And like I said, then that would mean that the containers that Ayup produces would be instantly available in Kubernetes without using a registry. Okay, so yeah, it ran Ayup. It returned an error because it didn't, not actually telling it to do anything. It's just going to output the help. But yeah, I mean, I guess one day we could have it so Ayup can run itself. which might be useful for development. I'll have to think about it. Okay. Yeah, that's it. I suppose, actually, one last point. Ayup, the server, doesn't produce any log output, which is a mixed bag. For logging and tracing, we use open telemetry exclusively at the moment. So if you want to like debug Ayup, then you need to pass the endpoint of where you're running something like Jaeger or whatever supports open telemetry, and then you'll get tracers, and the tracers have events on for every call that's made from the client to the server, which is really nice in a lot of ways. In some other ways, it's not so nice because like when a span is only half finished or something, it doesn't show up. So there's some slight annoyances like that. And then we also have continuous tracing or performance tracing implemented with Grafana Pyroscope, which I think I've used once to solve one bug, but comes practically for free with Go. It's like very little work to implement that. So we have a bunch of observability stuff built in there. At some point, this is another thing that at some point I need to redress and see whether we need just some classic logging as well for when you have situations where spans don't show up, or you don't have you haven't set up the collector, which of course, yeah, setting up the collector is, I guess again, it's another thing we could bundle into the server, so you could have like Ayup control panel with, Grafana setup or whatever. But yeah, that's something that's pretty cool at the moment for development. In the future, we'll have to address it again for usability concerns when people have problems. Okay, I think that's it. That's really it this time. Yeah, check out the GitHub repository. Maybe go to premai.io. That's all. Goodbye.